Who's a you favorite video game character? If the answer is Mario, I've got a great new Scratch tutorial for you today. We're going to be building a really simple little dodging game featuring Cape Mario and his flying nemesis, Bullet Bill. We're going to use real Mario graphics and sound effects. I'm going to teach you how to make Mario's costume change dynamically when he moves up and down. And you're going to learn how to use clones to make an army of flying bullets. This is a beginner level project, so you don't need a whole lot of coding experience to try it out. But if you click because, duh, it's Mario, and you've never tried coding before, you might want to check out Cat and Mouse, my introductory coding curriculum. It'll teach you everything you need to know to power up your own video games. And if you want to give Chromeworks a little power up, make sure to like and subscribe to this video. So let's hit the start button and get coding. Okay, so to get started here, you're going to need to load up this Scratch starter file. It's a file that has all of the graphics and sound effects you're going to be using to make this file. You can find it here in the file description down below, or you can go to my website, chromeworks.ca/lessons, to find this and all the other great content I've been putting out in Scratch. All right, so let's see what we have here. We have our main character, Cape Mario. We've got a couple of graphics here, one of him flying with his hand out, and a couple more of him with his cape flapping around here behind him. So we're going to have our character go back and forth between these different costumes depending on what you're doing with your keyboard. We're only going to be moving up and down in this game because it's a fairly simple game. We're aiming this particular release at Scratch beginners. So if you're brand new to Scratch and haven't done anything beyond the simple basics, this is a really good project to get you going. Nothing too confusing or difficult in here. And we've got the familiar Mario characters, who I know so many kids who are just getting started on Scratch are moving over from Nintendo units, so they're probably going to really enjoy this. So we've got Cape Mario here. We've got his nemesis, Bullet Bill. There's only one graphic of him. We've got this tiny little sliver of a graphic here called Border, and you can see it's just 1 pixel wide along the edge here. Kind of hard to see along the edge, but just a tiny little thing. That's what our characters, our Bullet Bill character, is going to be smashing into, and that's how he's going to know he goes off the left side of the screen. Scratch does have the ability to detect the edge of the screen using this command here, touching edge, but touching edge. But the problem is that our characters are going to start, let's hide this cover screen here. Our character, Bullet Bill, is going to start off the edge of the screen already. So if we tell him to detect the edge, he's just going to detect it right away. So we need to know that he's at the left edge of the screen, and there's different ways to do that. But one easy way is to just draw a little tiny border thing. We're going to hide it pretty much, and it's just going to be something that our bullets can collide into. I've got a game over screen, which I designed myself in Photoshop. And I've got a little thumbnail graphic here that we're going to be using as well. That is just going to be a nice little introduction to the game for people who are loading on it in the Scratch interface. All right, so we're going to start with Cape Mario here. As I said, we're going to be just moving him up and down. Let's hide these other graphics. So here he is on the screen. We're just going to have him move up and down depending on our keyboard inputs. You could do this with a mouse if you wanted to, but I think this is more of a keyboardy kind of game. So we're going to go, as always, we're going to start with our event called When Green Flag Clicked. That'll tell all the different sprites in the game to get started moving around and do what we want them to do. Now we have one variable here. We're not keeping a score. We're just keeping track of the amount of time that we've been playing the game for. So at the beginning, we want to set that time to 0. And that will start counting up from there. And we're going to do the time in a second here. At the beginning, we're going to play a little sound effect. I do have some sound effects loaded up here. I've got Mario saying, "Let's go." And I've got another one of him going, "Ow," when he gets hit. And I've got another one of him saying, "He's a winner." Now you can't actually win this game, so we're just going to have him randomly say it every once in a while when he finishes a level. All right. So let's go start that sound effect called "Let's Go" right at the very beginning. We're going to send him to a start position. The start position he's at right now is pretty good, so we're just going to drag over this block here, go to X, Y. That'll send him to the middle of the screen. I'm going to go maybe -210, just because I like nice clean numbers. And the Y, we want it right in the middle of the screen, so let's make that 0. So as soon as we click the green flag, he'll go right to the middle of the screen and say his little starter sound. And I think we're going to have him hide later, so let's have him show just to make sure, just in case he's hidden. Let's turn the game off right now. I've got some background music going. I should have cleared that off. Let's delete that right now. All right, I'll show you how to add that later. Okay, so now we're just going to start checking for keyboard inputs. We're going to check and see whether we've hit the up or the down arrow key. Now we're going to do that forever. I've told you guys a couple of times, but so there are some keyboard inputs here. There's one here called when I press a certain key, which is right here, when space key pressed. We don't like using these because they actually add a little bit of delay. You'll find that when you use these blocks, it's very, very sluggish and slow. So I try not to use these whenever possible, unless it's something that where it just press something to turn a button on or off. But if you're using it for a control, I suggest you don't do that. The better solution is grab a forever loop. And inside there, check and see. We'll use an if statement to check and see using our sensing blocks whether a key has been pressed. So key space pressed, and we'll change that to key up arrow. So if my up arrow key has been pressed, we're going to change our Y by 10. So that will move us up. Y coordinates being your up-down movements in the game. So we'll make our speed 10. You can change that to a higher or lower number if you want. And I'm going to do the same thing for going down. So I'm going to grab the if statement here and duplicate it and change this to say if I'm going down, then we'll change our Y by -10. So as you can see, this is a simple little movement technique here that'll get us moving up and down quite nicely. Now the one problem is we're allowed off the edge of the screen here. You'll actually be able to use this to hide from the bullets as they're coming at you. So we don't want to do that. We want to constrain our character so that when he gets to about here or so, he'll be stopped. So there's different ways to do that, but what we're going to basically say is we're going to tell him to ignore this up this up press of the button if he gets above a certain Y value. So we're going to say he's allowed to go up, but only if his Y position is less than this line here, which is right around a Y of 150. So let's go if. I'm going to put a second if statement inside the first if statement. Now you could say if key up pressed and another thing and have both those if statements be checked. But you can also put one if statement inside another. So since I'm trying to keep it simple today, I'm just going to put the one if statement inside the other. And I'm going to say if Y position is less than, we're going to grab a less than symbol, which is shaped like this, pointing to the left. And our Y position, we can find that little bubble at the bottom of our blue motion blocks. So if our Y position is less than 150, then we're going to be allowed to go up. So that means if our Y position is 155, for example, it's going to ignore this and not let you go up any higher. So no matter how hard you try now, you'll see that we won't be able to push up above that number. I can set that number to whatever I want. Let's say I push it to 120 here, for example. You can see that now I can't get above that number. So wherever it is you want to constrain your character's movement to, I thought 150 would be a good number, but you can pick whichever one you like. We're going to do the same thing down below. We need a second if statement down here. So I'm going to say if. I'm just going to drag that around here so that the Y is inside of it. Now I need a greater than sign because we're down at the bottom of the screen now and we want to make sure our value is above the one at the bottom of the screen. So let's grab another Y position block. If our Y position is greater than, and at the bottom we want the opposite of this one, the mirror image, so that's going to be -150. There we go. And so now our movement is constrained in both directions. You can see we can move up and down, but not too far. Excellent. Now the last thing I want to do here is to make it seem more like our character is flying. I want him to tilt a little bit. When he's moving up, I want him to tilt up. And when he's moving down, I want him to tilt down. And when he's moving in a neutral, when he's not moving at all, I want him to point straight. So we're just going to change the direction he's pointed using this command under the blue motion blocks called point in direction. I'm going to see if my Y position is pressed. We're going to point in direction 75, which is tilted a little bit up. Now the opposite of that, because he's moving 90 here, so that's 15 away, which means that pointing down here under the Y is going to be 105, which is 90 plus 15. Okay, so far so good. So let's check that out. You can see that he points up when he's going up and down when he's going down. Beautiful. Just a subtle little thing. You can make that a little more extreme if you wanted to, just by increasing those numbers. Now, as I was saying, we need him to default back to straight when we're not pressing a key. So to do that, we need to figure out when he's not pressing any buttons. Now there's no pressing no buttons command in Scratch, but there is one called pressing any key. And there's another green operator here called not. So we're going to use a combination of those to figure out whether we're not pressing any keys. Let's add another if statement down here below. And we're going to say if, grab our operators. We're going to grab the one that says if I'm not. And then we're going to go to our sensing blocks and grab the keyboard input, which says key space. And I'm going to change that to key any. So if I'm not pressing any key, if I'm not pressing anything at all, we're just going to make him default back to pointing in direction 90 here. Okay, let's try that out again. Click the green flag. And you can see that he points up when he's going up and down when he's pointing down. And he defaults back to that right-hand position when you're not doing anything. Perfect. Now we also want to animate a change of costumes here. As I said, he has kind of a flapping animation here that he cycles back and forth between. We can't do that inside the main code because if we got him into a loop here where we were cycling between costumes, he wouldn't be listening to see if he was going up or down. We have to, if we want two things happening simultaneously in a game and we don't want them interfering with each other, we have to start a separate stream of code. So we can have more than one green flag in a project. That's something a lot of noobs don't understand about Scratch, is we can have more than one green flag going, and both those programs will be able to work simultaneously because the computer's fast enough that it can think of two different things at once. So this block of code that we've just designed here is going to control his up-down movement and the tilt of his character. And this next one, so let's grab a new green flag, is just going to determine what costume he's wearing. So let's grab a forever because we want him to keep changing costumes throughout the game. And we'll grab an if-else statement, which is a little different from an if statement that says do this unless if this is true, but if not, then do something else. So when you're doing an if statement, it will ignore the entire statement if it's not true, but with an if-else, if it's not true, it'll have a default, something that it goes back to. If he's flying up or down, he's going to be wearing the flying costume, and if not, he's going to be wearing the idle costume. So we're going to say if I'm pressing one of those keys, so we're checking now to see whether there's two different keys being pressed, one of two keys, so it's this key or that key. Let's grab an or sign and put it in the if statement, and let's go back to our keyboard inputs, and we'll grab key space pressed, and we'll grab a second one here, and we want to change this to up arrow or down arrow. So no matter whether I'm pressing up or down, we still want the same animation playing, which is the fly costume. So let's go to our looks commands here, and we'll switch costume to the one called fly. Now, if we're not moving up or down, we want to go through the different flapping animations here, these two different animations called idle 1 and idle 2. So we're just going to grab a couple more costume changes here. One for idle 1 and one for idle 2. Oops. In between, because the animation is going to be going so quickly we won't be able to see it, we want to add a little bit of a delay here. So let's go to our control blocks. We'll grab wait 0.1 seconds after we change our first costume, and then another 0.1 second after we change the next costume. Let's pop that all inside the else statement. So if we're not hitting any keyboard commands, you can see that's already running now. And our character is flapping along nicely. And then when we go up, you can see he's moving he changes to a different animation. Now why, yeah, I haven't clicked the green flag here. So you can see now our animation is looking a little more interesting here. So he's moving his arms and tilting his body when we go up or we go down. I haven't mentioned, by the way, that this game was coded by one of our own Chromeworks students, Super Cannon. So Cannon's a 14-year-old student from Oregon, and he's made many fantastic games. He admits that this isn't the most sophisticated game he's ever made, but it's a great beginner level game. And so thanks to Cannon for coding this for us. All right, so our Mario movement's working beautifully now. I think we're just good to go with that. Now, the only other things we need to do here are collision detection. So we need to see whether our guy has been hit by something. And we're going to control our timer through the Mario cannon. We could do it anywhere we wanted to, but I think we're going to do it inside the Mario character here. So let's do that next. We're going to go when green flag clicked. So this chunk of the code is only going to look at the timer. We're going to set we've already set our time to 0. Yeah, we already set our time to 0. So all we have to do is we'll grab a forever here and we'll just start that timer running up. We're going to go forever, change time. We're going to change a variable. Now changing time by 1 forever is going to make that go up like crazy. So we need to actually just slow down that change of variables to have it happen once every second. And that'll actually keep track of our time. You notice we can't see our variable up here because it's hidden. We actually want it that way because the time's only going to appear at the end. Now you see here it doesn't actually say time. Let me bring it back to the normal readout again. So the default way that Scratch handles variables is to have them pop up on the screen here and say the name of the variable here. We don't want that because our game over graphic, let me show it to you here, has a little spot that says you lasted something seconds. We don't want it to say time. So I'm going to right click on it and that shows up a little menu here that lets us change to something called a large readout. The large readout is bigger, but it doesn't have the name of the variable here. And you can see that this is looking a little more sharp. We don't need to look at it right now, though. We're going to hide it when the game begins and then show it when it's over. And we're going to control that inside our game over graphic, so we'll be dealing with that later. I'm just going to hide it again right now so we don't have to look at it. While we're here, we might as well finish our Mario character. So let's go back to Mario here. And we're just going to do our collision detection here. We're going to check and see whether Mario is touching one of the bullet bills that are flying across the screen. So let's do a separate screen with the program for that. And we're going to go forever, when green flag, forever, if we're touching bullet bill. Then we're going to make an ow sound. So let's go start sound. Ow, which you remember is an ow sound. And we don't want to be able to keep moving once that happens. So we're just going to do a stop command here. So if you go to control towards the bottom, there's a block here that says stop all. We're going to keep the background music running. So we don't want to stop the whole game. We just want to stop Mario here. So I'm going to hold down the option button here under my stop and pick stop other scripts in this sprite. That'll stop all of Mario's movement and all the rest of the stuff. There we go. We're going to send Mario back to his start position again. So let me just bring him back to a start position so I don't have to re-enter these numbers. So we're going to go back to -210, 0. And we're going to send a message over to the game over sprite telling it to appear. So that's a broadcast. Whenever you want one sprite to tell another one what to do, you generally send a broadcast a message. So we go broadcast. And there's already a game over in here, but if you wanted to create a new one, you know that you can just go new message and then type the name of your message over here. So we're going to go broadcast, game over, and that's all there is to it. So we're done. The Mario character, as I said, this is not a super complex game. We've got everything we need here, and he's ready to start detecting when he's bumping into the Bullet Bill character. All right, so let's go over to Bullet Bill, and we'll get him coded next. All right, so there's only one graphic for this guy. It's not too complicated then. We're just going to start spawning him. So we're going to use clones, which is we're going to have Bullet Bill make a copy of himself. Now, in the earlier version of this game that Canon put together, he just made a whole bunch of Bullet Bills. He made 7 or 8 of them and had each of them showing up at random times. So a more compact and efficient way to code this is to make Bullet Bill make copies of himself. He's going to stay hidden here in the middle of the screen, and he's just going to pop over and create a copy of himself, and that copy is going to start sliding across the screen. All right, we don't want them moving right away because you need time when you click the green flag to move your hand back over to the keyboard commands if you're using your right hand here, so that you don't get slammed before you even get a chance to start playing the game. So let's go wait 1 second. We'll go to our control blocks. Wait 1 second. Now let's grab a forever, because we're going to be making clones until the game is over. So we need to keep doing that forever. All right, we're going to make our clones in batches of 10. So I'm going to grab a repeat 10, and this will get us through making clones 10 times. And then we're done. We'll have a little pause, and then we'll make the next 10. So time for them to whiz past us, and then we'll create the next one. So creating clones is done through the control blocks. There's a command right down here at the bottom called create clone of myself. And underneath there, we don't want them all spawning simultaneously, so we're just going to put a little bit of a delay in there. I'm going to go grab the wait 1 second, put it right below, and I'll change it to 0.2. And that'll put a little bit of a pause between the creation of these guys. So it's going to go over and make 10 copies of itself. And then when it's done, it'll exit this repeat loop. Then it'll wait again, and that'll give us time to clear that round before we finish the next one. So wait 2.5 seconds. Now I have a variable here called random chance that I created, and that's just going to be checking to see whether he should say I'm the winner. We don't want him to say it at the end of every round, so we're going to basically have him do it randomly, maybe about 1 in every 4 times he finishes a round. So I'm going to grab an if statement here. And first we want to, before we put the if statement in, we're going to go to our variables. We'll set that random chance. We want to basically roll a dice here to pick a number from 1 to 4. So set random chance to a random number. So we're going to go to our green operators, pick random from 1 to 4. So that will generate a random number from 1 to 4. And whatever that answer is, we'll say if the answer is a 1, so we're going to grab an equal sign. Now I need something here that says random chance. I'm going to go to my variables. I'm going to say if random chance is equal to 1. So if I rolled that 4-sided dice and I got a 1, then I'm going to just say that sound effect. Now it's not going to interfere with anything else in our program. It's just going to make that sound and the game will continue. So there's the winner sound. You'll notice that the winner sound actually exists inside of the Bullet Bill here. I copied it over here by dragging it over from the Mario character into Bullet Bill. That's really important because you only have access in Scratch to the sounds that apply to that belong to that character. So if I wanted Bullet Bill, for example, to say the other Mario sound, like ow, for example, it's not available because it's not a sound that Bullet Bill has available. But I could bring it over by dragging it over to Bullet Bill. And now you can see that ow is one of those sounds. I don't actually need it, so let's just delete it from there. All right. So start sound winner. Okay, that's actually good. So now every once in a while, and I'm not going to test this now because it will probably take a while for that to happen. And we don't have our guys being spawned properly yet anyway. All right, so we're creating clones. They're basically being created right in the same spot that our character is. So we need to tell our clones what to do so that they show up on the right-hand side of the screen in a random position at a random height, and then wait a little, and then start whizzing across the screen at a random speed as well. All right, so the command to order clones around, to boss them around, is called when I started the clone. It's down at the bottom of our control blocks, when I started the clone. The first thing we're going to want to do is tell our clones to stay hidden until they're ready to start shooting. So let's go hide. And we're going to wait. So we've already waited a little bit. We've waited 0.2 seconds, but we're going to wait a random amount of time as well before these guys show up. And so we're just going to add on top of that 0.2, we're going to add another fraction of a second. So let's go to our control blocks. We'll go wait. And we're going to pick a random number here. So instead of waiting a fixed amount of time, we're going to say wait sometime between 0.1 and 0.4 seconds. So basically, they're going to wait anywhere from 0.3 seconds, because we're waiting 0.2 plus 0.1, so a minimum of 0.3 and a maximum of 0.6 seconds before they launch and they start moving towards you. All right, we're going to send them over to their start position here. So we're going to say go to. Now the X is 235, which is the far right-hand side of the screen here. The maximum distance here is 240, an X of 240. So we're going to have them almost off the edge of the screen there. And the Y, the height, we're going to make a random number. So let's go pick random and put it into the location where the Y coordinate is. And we're going to tell him to go up to a height of 150, which you'll remember is the maximum height that we allowed Mario to go as well. So we're going to go between minus 150, which is at the bottom of the screen, and 150. There we go. So that will constrain the height of the bullets to match the height that Mario is able to go as well. All right, now that we've waited and we've put ourselves into our start position, we can show. So let's go to our looks blocks and grab a show. When they're visible, we want to give Mario just a fraction of a second to see what's going on here so that he can get out of the way. We don't want the game to be too hard, so we're just going to wait 0.2 seconds here. And then we're going to get them to start moving, changing their X coordinate by a negative number so that they move across the screen here. And we want them to keep doing that until they hit the border. So we could say move and then if touching border, delete the clone. But we're going to do it a little differently here. We're going to go repeat until. So they're going to continue their movement cycle until they're touching Mario, which will create a game over event, or until they're touching the edge. Either way, we're not going to need Bullet Bill anymore. So we're going to delete the clone after that. So we're repeating until two different things are happening, either of those. So I'm going to go or in here, grabbing a green block. So touching, we're going to go to sensing here. We'll say touching. So repeat until I'm touching Cape Mario, or I'm touching the edge of the map, which is not edge, but border here. There we go. All right, so they're touching that little invisible border object on the left here. So, as I said, we just want them moving by going change your X. Let's just start them at -5 here. We're going to change that in a second here. I just want to demonstrate what this is going to look like here. So they're going to start moving, and then when they're done, when they've touched one of our two characters, we can delete the clone, get rid of that temporary copy we created here. So let's go to our control blocks, and we'll go delete this clone. So it's outside of the repeat loop, so we're going to be moving and moving and moving until we're done moving and touching one of the things, and then we're going to delete this clone, and that'll get rid of it. Okay, so we're actually ready to start playing here. Let's go click green flag. Uh-oh. So you can see that our characters are being formed randomly here, and our game ended. All right. Actually, I didn't delete the stuff inside the game over. Let me do that right now. All right. So this is working fairly well. We're going to make it a little more interesting in a second here. Let me hide this guy. So we forgot to hide the original Bullet Bill. We're going to want him hidden. Let's go under the green flag here, and we'll add a hide command. That'll tell the main bullet bill to be invisible here. And then our clones are only going to show up in a second here. So let's click the green flag. And you can see their bullet bills start to appear. They hover for a second. And then they start moving. Now, this game's a little bit easy. We're going to want these guys faster, but we're going to want them to go at an inconsistent speed. So what we're going to do is, instead of having them change their x by 5, we're going to have them change their x or their horizontal speed by a random number. So let's go to our operators, and we'll pick a random number. So the minimum speed is going to be -5, and the maximum speed is going to be -30. So that'll get some of these guys whizzing across the screen quite fast, and some of them slower. And now watch how the game changes now that we've added that. And suddenly, our guys are moving at much different speeds. That helps to spread them out a little bit, so you have a little more horizontal room to get away from these guys as well. So, ironically, moving them faster or at a random speed, instead of making the game harder, it makes it a little bit easier, because now we have room to dodge past one of these bullets and not get in the way of the other one. All right, that's looking really great now. You can see that our character is moving back to a start position right now, but the game should be ending when that happens. So let's trigger that event now. We'll go over to our game over sprite next. And actually, I think there's one other thing we have to do inside bullet bill here. And that is, yeah, there's a game over event here. We need to stop these bullets moving when there's a game over event. So let's go back to bullet bill for just 1 second here. We just have one little bit of code to add. So we're going to go to our events. We'll go when I receive game over. We need to basically stop this guy moving, just like we stopped Mario moving. So we'll go to our control blocks, grab a stop all, and say stop other scripts in the sprite. Okay, now we actually are done with the bullets. Let's go back to our game over sprite now. We'll grab a green flag to tell this guy what to do at the beginning of the game. And what we want to do is just make sure he's in the middle of the screen in case we accidentally move him around. So we'll say go to 0, 0. We want him to hide at the beginning of the game. So let's go hide. And we're going to hide this variable. You see, we still have this time variable stuck on the screen here. We can go to our variables blocks and grab a block here that says hide variable. And we're going to hide that time variable at the beginning of the game and only have it show up at the end. So when I receive game over, we're going to make our game over screen show. And we're going to show that variable for the time. So show variable time. There we go. We've already added some nice functionality to the game. Let me show you that now. So I'm dodging bullets, and when I get hit by one, there we go. And that's good. Whoa. So we got some weird stuff going on with the audio. We'll look into that in a second. So you'll notice that our Mario character is still here. We could hide him after we die, but the easier thing to do is probably to bring him to the front. So we're going to go to our looks commands here. We'll go to front layer, and that'll bring the game over in front of our characters here so that our Mario is not visible anymore. There we go. That looks better. I have to align this time object here a little bit. There we go. That's looking a little nicer. All right, that's all there is for our game over character. Our border, let's click on that. I already have some code in here, and I'm not sure if it's in your starter file or not, but I'll probably end up deleting it. So when green flag clicked, we want this guy to show. We want it to still collide, so we're going to set our ghost effect to... Normally we set it to 99 here, because sometimes Scratch has difficulty detecting objects when they're ghosted or made totally invisible. But 99 will make it so that they can still collide quite effectively, and it'll still be basically invisible. All right, that's all there is for the border. Now we have a thumbnail here, and let me show you that again. We've got to hide this to make it visible. So our thumbnail, I'll just show it to you this way. Again, something that I designed in Photoshop, just a little preview of the game. We want this showing up all the time, so we're going to use that ghost effect to make it invisible while we're playing the game, and it's going to become invisible. So it'll become invisible when we're playing the game, and as soon as we stop, that ghost effect will stop functioning because it only works while the game is running. So let's go to our looks commands here, and we'll go set color effect, and we'll call it ghost effect. So we want it to turn invisible. And so as I said, the really cool thing about that is when our game is running, it'll be invisible. And then as soon as I hit stop, you see that it shows up again. So that's a great way to do a thumbnail. The nice thing about these thumbnails is if you set the game up so that this is running like this, and then go back out of the game, go to your project page, and then finally exit your game, this will be the little thumbnail that is actually shown on the Scratch homepage. Let me demo that for you. So if I go to my project page, which will automatically save the file, and then I go back out to my Stuff folder, you'll see that my Mario Dodge thumbnail will be visible here. And so it'll be just a nice way to look at what's happening in a game. You don't want your thumbnails to look like they're a game in progress, like this, for example, right? You want to be able to see something that actually has the title of the game in it. And so that's why we tend to use those thumbnails. Okay, I need to get back into my game again. So let's get into this version of it that I'm working on right here. All right, and the last thing we're going to have to do is our background music. So we've got a backdrop set up here, a nice Mario looking little backdrop, and there is a music file set up here. So let's go click on that. So back to our code again. Now we're going to say when green flag clicked, we're going to play that audio file, which is just a nice little bit of Mario music. I'm not sure which game this is from. It says Mario and Luigi Final Battle. There we go, and this is a file that was supplied to me by Canon, so I'm not quite sure what which Mario and Luigi game that one's from. All right, so because we're playing background music, we can't use the start sound command, which we always use for background sounds. If we go start sound here, it's going to do some wacky stuff. And the sound will never get a chance to start because it'll just keep restarting it again. There's actually blank at the beginning of the file. It'll just keep restarting it. So we actually want to go play sound until done here. Play sound until done. And so that'll keep playing through the entire thing, and then it'll loop around and play it again and just constantly keep doing background music. So that's how we do background music in Scratch. And you can see here that our game's working beautifully now, and I think we're basically done. So let me just play around. And here comes the second round. And I'm going to play here till hopefully Mario says his little random thing. I've been practicing, if you can tell. Yeah, there you go. So we just will randomly say that every once in a while. All right, and at some point you'll get hit. Here we go. We lasted 28 seconds. Beautiful. And the music will keep going. You notice we haven't stopped the music here, and I did that on purpose because I think the music can keep playing here until you stop playing the game. At which point, hold it. Oh, there's our Mario Dodge graphics that show up here again. All right. And I think we're basically good to go here. So I noticed that that Mario is still visible here. I think we actually need to add one little bit of graphic here that tells him to hide, a little command here that tells him to hide. So I'm going to go when I receive game over. Do I already have a game over in here? No, I don't, inside the Mario character. Let's tell him to hide. That'll get him off our screen. And we already have a show there, so we're good to go. All right. So as you can see, When I get hit, he's no longer visible on the screen there. And then when I hit stop, oh, our thumbnail still isn't showing. Let's have it go to the front. So let's say go to the front when the green flag is clicked. And that'll make it so that after I die, when I hit the stop command, oh, we're gonna have to tell him to go to the front constantly. So let's put that inside a forever loop here, because it looks like the other guy's going to the front here. Let's try that one more time here. Just a few little bugs to iron out. There we go. So we got our score, and then when I stop the game, there's our Mario dodge again. Beautiful. Okay, so that is it. I told you guys it's a fairly simple game, really suitable for beginners. Make sure to try and remix this game if you're interested. You can change the characters around and add any kind of different motif you want to. Canon here actually came up with his own remix of the game that turned it into a space game. Let me show you that right now. He hasn't completely modified it, so it still has some of the original Mario stuff, but he was just trying to demonstrate here how you can take the same game and give it a totally different look. So we've got a spaceship game here with a space background and meteors heading towards you. So there's a million different ways that you could customize this game and create different stuff. We'd obviously want different sound effects and different graphics in there. But so if you do come up with a remix of this game, please share it with me. If you go to chromeworks.ca/lessons, you'll find a link to the remix room where you can save these files, and I will show them on my weekend live streams, which air every Saturday at 10 a.m. And I will hopefully see some of you guys online there. I hope you enjoyed this. Please leave a comment and like and subscribe if you enjoyed this video. Thanks, guys. Bye now.